I had an iron rabbit plane like this years ago, and I was up on a ladder and I dropped it and saw it receding down towards the floor, and when it hit, it just shattered. The cast iron breaks like china if you hit it too hard. And I loved that plane. I always wanted another one. So I decided this week to make one pretty much like it as close as I could. And this is how it happened. I ordered a piece of 1 inch thick A36 mild steel. This is like the world's most generic steel that they make, bridges and heavy equipment, sort of frames of buildings out of. So I just ordered a chunk of it and started sawing out the shape of my plane as marked with a Sharpie pen. You can work metal with high-tech tools if you want, but I keep it pretty simple. Mostly the stuff is cut out with a hacksaw. I did start using a power hacksaw a little later. I got tired of sawing it by hand. And I have a milling machine that you can see there in the background. It's sort of like a drill press, but it also cuts sideways. You just clamp things down to the table there, and then you can kind of slowly move them back and forth under the cutting head. But this is pretty low tech. You can do all this without much more than an electric drill, really, by way of power tools. So the idea here is it's pretty close to square, so I'm going to lock it in this vise, and the vise is mounted on a sliding table that can very slowly be cranked back and forth under that big cutter head. So I'm going to I just picked the best side that looked the flattest and put it down, and now I'm going to cut the other side to exactly parallel the table, which is pretty close to parallel to that other side. Then once I get that perfectly flat surface on it, I'm going to take it out of the vise, turn it over, and cut the opposite side. And now that's cut against a really perfect reference surface. So that gives you two perfectly flat sides. And then with two perfectly flat sides, you can get the third and fourth sides, as we'll see in a minute. I'm not going to worry about the big flat sides of it yet. I'm going to leave them with the rough mill surface on them, the sort of mill scale. It's quite hard, and I don't want to take it off with these expensive cutters. I'll just grind it off later. So that's what's going on now. There's just quite a few minutes of going back and forth, taking off a few hundredths of an inch at a time until I get 4 flat square surfaces. Now I've got 2 really smooth, flat, shiny sides on it that are perfectly parallel. See how nice they are? With these machine tools, you're actually working crudely down to, 1/1000th of an inch or so. And if you want to be fine about it, with these machines, you can get down to a few 10,000ths if you're really trying. But because things have to be reasonably accurate like that, you have to square up the tools. So that's what I'm doing here, is that little gizmo with the little finger that's touching the vise is sensing distance. As I go back and forth, it'll tell me I'm a little out of square, so I can tap it over just a little bit and until it slides back and forth without moving the needle. So that's what I'm doing now. It's a very tedious process, but necessary to getting good results. Now that it's squared up, I'm going to put in a different kind of cutter. One that's called an end mill. It cuts either on the bottom or on the sides. So I'm going to use the sides of that. You'll see I'm going to go back and forth over the end that's perpendicular to the smooth sides I just cut. We'll go back and forth on them, and then that'll make it really square. So here I'm set up to trim those ends, and you'll notice I'm going to use the side of the end mill, not the end of the end mill, and just I'm going to go back and forth. Now, this is heavy steel. It's a big cut for this. This is a little teeny baby mill, so I can't really cut more than maybe 20 or 25 1,000ths on a pass. So that's, you know, just like a couple of hundredths of an inch at most. But you'll see as I go by back and forth a couple of times, it'll bring it all down to where it's freshly cut metal, which means I've really only the entire saw discrepancy was only a few hundredths of an inch. Yeah, I'm going to speed it up now and go back and forth a lot faster. It's not going anywhere near as fast as you're seeing in this picture. See, I got about a third of the way across with cutting all new metal. So that's sort of an indicator of how close to square it was just by eye. There we are. Now I'm just going to do this to both sides, and now we'll have a perfectly rectangular block of metal. Yeah, look at that. It's amazing how accurately and finely a big heavy machine like that cuts. See, it's just perfect. You'll see I've drilled a couple of relief holes in here. I did that sort of off camera, and I'm just hacksawing in to take some chunks out, because I'm gonna use a milling machine to carve out that sort of open space in the middle of the plane. So it's just a bunch more sawing here. I'm not going to show it all, but I'm using those holes as a place to saw too. So now that it's roughly kind of hacked into shape, I'm just going to clean everything up on this belt grinder. I got it off camera. I got it very, very square. You know, it's takes a little fiddling to get it perfectly square. Otherwise, you're going to end up with all lopsided shapes. But this is just a matter of grinding for a minute or two and then soaking it in cold water to it gets blistering hot, and just grinding and cooling until it gets a nice outside shape. It's kind of fun, actually. This is exciting and dramatic. Yeah, here you can see that the body of the plane is pretty much shaped. So I'm using the milling machine with an end mill to go back and forth, removing metal from the middle. Now I actually did this wrong. I made the first slot the full width of the end mill, but it meant that it would be turning the wrong direction in the easiest way to widen it out. So what I should have done was cut it closest to the near side, and then as I came in to widen it, the end mill would have been coming in under the metal instead of trying to drag itself forward, which leads to a lot of problems with a flimsy little mill like this. So it's just a lot of back and forth, shaving away about 25 1,000ths of an inch on every pass. So here I'm widening it out, just again going back and forth, you know, 25 thousandths or so at each pass. These recordings are in real time, they're not speeded up. So you can see it's a tedious process. And here's the result. The slot widened out at the correct angle for the blade. The workpiece won't fit in the vise and still leave enough room above it when it's vertical, so I'm clamping this plate to the table, and I can then attach the pieces to that to drill. And here are just some different shots of using the milling machine to cut various holes and widen things and generally shape the major pieces. So I marked up the steel for the tongue, it goes in the middle, and then decided, oh, this is too much work to our handsaw. So I took it in the other room. Here I am just starting the cut with a hacksaw, and then I'm going to finish it up with this Sawzall, which is faster. Now I don't know why I'm making such a face. I always look like I'm, like a judge about to sentence somebody to life in prison. But this is actually fun. I'm having a good time. And then there's lots and lots of grinding that comes after that to get it the curves nice and fair and make it look pretty. And this is also fun, and I'm also making a really horrible face. So I guess I just have resting stern face. Time to take the mill scale off the sides, and you can see how unflat the sides actually are. It leaves a big hollow spot full of mill scale in the middle without a lot of grinding. Here's before and after grinding. Really makes a big difference, right? I've bored holes for the pin that holds that lever in place. Now I'm going to tap one side, which is what I'm doing now, and the other side is full width. It's a 1/4 inch. The part I'm tapping is smaller. So I drilled the whole thing through with the small size, tap it, and then I'll bore out the part that the pin just slides into. This is very nervous work because these taps snap off, and then they're the devil to get out of the metal. Sometimes you can't get them out. So this is just a matter of threading the pin that goes in there, just one end of it. The little pin is more work than you might think. Here I am threading the end of a long rod. So this will slide right through a hole on one side and then screw in on the other side. This is not as nervous as tapping because these things don't just snap off and get stuck. But here it is getting threaded. I guess I'm done now. I'm going to back it off, and that's all complete. It's on the end of a long rod, so I put it in all the way, then mark it and saw it off with a hacksaw. After it's sawed off, I have to then trim it to exactly the right length on both sides, and we'll see that in a minute. But this is just sort of tedious, repetitive work, sort of tapping things and threading them. See, now it's in place. I'm going to trim it down with a file just to make it nice and smooth. I love files. They're one of those tools you don't think it's going to work, and then they work so well. They're really actually kind of fun to use. And here I'm putting the slot in the screw at the end. Kind of have to get it just right, or it'll really show up as looking lopsided. But this is just a little tiny cheesy hacksaw. I think it's an X-Acto brand that I found somewhere. But the threaded end is still too long, so I've got it locked in the vise here. I'm going to just cut that off, and then again take the file and cut it down perfectly flush with the side of the plane. The screw that applies pressure to the lever to hold the blade in place is made of brass. I made it on the lathe. You could actually do the same thing with a manufactured steel screw, machine screw, but I have the lathe, so it's nicer to do it this way. This is just, again, several steps of making it smaller and smaller. And once again, I use the die with the tailstock holding it perfectly perpendicular to the rod to thread the screw. I usually just start it this way and then finish it with the screw held in the vise. You just need to get a 1/4 inch or so of it threaded, and then it'll hold itself perfectly steady thereafter. So you can see why it's tedious to do it on the lathe. So I'll finish up those threads with the screw held in the vise because it's just easier that way. The hole it screws into has to be threaded manually, of course, at an angle, same angle as the blade. So here I'm doing that and offering silent prayers that I don't snap off the tap in the hole, which seems to happen at the worst possible moment every time. The screws to hold the bullnose on have to be drilled the small size to thread through the bullnose piece, then copied through those into the body of the plane, and then subsequently re-drilled with the full 1/4 inch hole to accommodate the unthreaded part of the screw. This is really just a pain in the neck in terms of work holding because the pieces are small and it's hard to get them to stay in position. But it worked, and as you can see here, at the end of this, I'm just widening the holes in the bullnose piece. So the thing is pretty much done now. There's a lot of little trimming, so I'm going to take the file and like shave down the bullnose so it doesn't quite perfectly line up, and get everything sort of trimmed and flush. The file actually leaves a pretty finished surface on it, but it's not perfect. So once it's all filed as smooth as it can be, the last step will be manually grinding it down with wet and dry sandpaper. It's kind of satisfying to do this at the end. I just lay sandpaper down on this hardened granite block. I wouldn't do this with a surface plate normally, but this one's pretty roached out already, so it's fine to do this on it. So just rub this back and forth on it. Keep looking at it to make sure it's all grinding down evenly. And yeah, I just do this with 120 grit first, and then followed up with 240, and that gets it about as polished as you'd ever want it to be. There's nothing really beyond that. 220 is not very fine for wood, but on steel it takes off so little metal that it gives a good result. So here's all the pieces we made, plus the blade. I didn't make the blade, I just found it in a drawer. I might have made it in the past, I'm not sure. But there you go. And here it is put together. I hope you enjoyed the video, and I'll see you next time.